Okay, so we're going to go ahead and look now at polyatomic ionic bonding. Polyatomic ionic bonding. So the polyatomic ion, once again, is that group of atoms that are all stuck together, covalently bonded, and they, as a group, have gained or lost electrons and formed an ion. So the first thing we're going to do is go from the name to the formula. Okay, our first example magnesium nitrate. Okay, turn to your neighbor and tell them what sounds familiar in this name and what's new. Okay, so tell me what sounds familiar. The magnesium, right? So Mg, that's the same that we've used before. Magnesium is a main group element. It's a main group metal. So it's in group 2A. So it will always form a 2+ charge. That's our cation. The new part is the nitrate. Okay? So specifically, the 8 is new. The ending of 8 is new. Before, we had nitride. Okay? And now we have nitrate. The ending gives you a clue. So for this class, I'm not asking that you memorize these polyatomic ions. You have a chart in the back of your notebook that you can use. So I am going to ask you to look it up. Okay, so if you're ever not sure if it's a polyatomic ion or not, just check the chart. That's all you got to do. Okay, so if I'm looking at the chart, I'm trying to find nitrate. Right here, they're in alphabetical order, nitrate, and I look over and I see NO3, 1-. Now we know we don't normally write the 1, but on this, the minus sign would be so small, it'd be hard to see. So that's why the 1's here, but really it's NO3-. So we have a group of atoms, our NO3, and the whole thing has a charge of 1-. Okay, so if we're looking at our example, I have the same way that I wrote my anions before, I'm going to write it now. It's just a group, NO3, and the whole thing has a -1 charge. The whole thing has a -1 charge. So if I think about how I'm going to write this as an actual compound, if I just crisscross these charges, then I have Mg, NO3, and if I crisscross them, then I would have 2. Does this look right to you? Because what this is saying is that we have 32 oxygens. Is that right? No, we need 2 nitrates. And so to show that I need 2 nitrates, I'm going to use parentheses. Isn't that what you do in math? Don't you use parentheses when you need to show you have 2 of a group or 3 of a group? It's the same idea. So what this means is that I have an Mg2+, I have an NO3-, and another NO3-. That's what this 2 means. So in math, the coefficient is like in front of your parentheses. And when we're writing formulas, it's the subscript after the parentheses that shows us how many we have. That's what this 2 means. So turn to your neighbor and tell them what the 2 means. So if I write this as my formula on my notes, I'm going to write Mg, because your cation still goes first, parentheses, NO3, because it's a group and I need 2 of that group of ions. And if I check, this is still a neutral compound. I have two pluses and then a minus, and that all adds up to 0. So I still have a net neutral compound. That's it. It's the same process that we were doing before, except now one of our ions is a group. Let's make a quick note and then we'll do some more examples, okay? So, polyatomic ions are a group of atoms that are combined to form one ion with an overall charge. So polyatomic ions are a group of atoms that are combined to form one single ion with one single overall charge, and that's either positive or negative, and it is the number depends on how many electrons the group of atoms gained or lost. Okay, the important thing when you're looking here is the name. So names are normally 8 or 8. There are a few exceptions to this, because this is chemistry and there's always exceptions. But most of them are 8 and 8. If you're ever not sure, just check the chart. In fact, let's write that down. Check the chart. And our chart is our common ion chart, which is located in the back of our notebook in our reference area. Okay, here we go. Let's do another example. Aluminum dichromate. Aluminum dichromate. Okay, well, aluminum sounds familiar, right? So we've used aluminum before as one of our main group cations. So I'm going to write aluminum, and I know that aluminum is in group 3A as a metal, so it's going to lose 3 electrons and will form a 3+ charge. The new part is the dichromate. Okay, well, I hear chrome in there, which sounds like chromium, which is a clue, but I've never seen an element that says dichromate. We've never used one like that, and the ending ends in "ite." So if I look in my chart, I'm going to see if I can find dichromate. Well, it's not in the positive cation side because there's only one. It's not in the 1-, but here it is in the 2-. So my dichromate ion is Cr2O7, and the whole thing has a charge of 2-. This is my peanut M&M for my dichromate. It's a group. That's the group I can't split up. Okay? So if I'm writing this in for my notes, my dichromate is right here. Then I have Cr2O7, and the whole thing has a 2- charge. Okay? Alright, so now I'm going to think about this in terms of crisscrossing. Now I gotta crisscross this to make a neutral compound. Well, I need all of this to add up to 6. Yeah? 6 pluses, 6 minus, because that's your common number between them. And if I crisscross this, I'm going to end up needing 2 aluminums and 3 of my dichromates. So if I crisscross it, I would have Al2, Cr2O7, 3. Does that look right to you? No, because right now this tells us that we have 73 oxygens. Nuh-uh. We need 3 dichromate ions. So what we can use again are parentheses. So parentheses, parentheses. Now this is saying that you have 3 dichromates. So again, what this means is that I have 2 aluminum ions and I have 3 dichromates. This is a neutral compound. These are peanut M&Ms and you can't break them up. It's just a group. They come together. So when I'm writing this for my notes, I'm going to say Al2 parentheses Cr2O7 in parentheses 3. Same thing we did before. We're just using a polyatomic ion now. Here we go. Let's do another one. Ammonium sulfide. Okay, ammonium sulfide. Well, we know the cation's written first. Ammonium. That doesn't sound like any element I've used before. There's no element ammonium on the periodic table. And if you're ever not sure, just check the chart first. Now I know that since it's written first, it's going to be a cation because it's written first. So if I look at my chart, there's only one polyatomic cation that's on our chart, and that's ammonium. And this is an NH4, and it has a +1 charge. So what this is a nitrogen and 4 hydrogens that are stuck together, that are bonded together, and as a group, they lost an electron. Okay, so it's a whole ion that has a +1 charge. But we're going to treat it the same way we just did aluminum or magnesium. It's the same idea. So if I'm writing out my crisscrossing, I would have NH4 with a +1 charge. Sulfide. Okay, that sounds familiar. Sulfide. Well, the "ide" is a clue, but if we weren't sure, we could look on the ion chart I gave you, and if it doesn't say sulfide on it, then we're talking about something on the periodic table. So sulfide is not on the ion chart. So that means we're just looking at sulfur from the periodic table. And we know that sulfur, as an atom, when it gains or loses electrons, it will gain 2 and form a 2- charge. Okay, so if I crisscross this, I need 2 of those NH4s. I need 2 of them. So I'm going to use parentheses again to show that I need 2 of that group. NH4 2S. Because what this means is that I have 2 ammonium ions and 1 sulfide. And a plus and a plus and a 2- adds up to 0, which means this is a neutral ionic compound. Let's do one more. We got to throw in a transition mode here. Okay, take a second and see if you could work this one out. See how far you get. Iron, iron to sulfate. Iron to sulfate. So think about what you know already and what resources you have to solve this. Don't just wait for me. See if you can solve it. Okay. Iron 2. That tells me this is a transition metal, but I know from that Roman numeral that this is has a 2+ charge. So Fe is iron. This Roman numeral 2 tells me it's a 2+. So that's my cation. That one we've done before. Sulfate, 8. That's new. The 8 ending and the ite ending is like ding, 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 check your chart. Okay? So if I look on my chart, there's only one positive cation, so that's not it. Plus it's written second, so I know that it can't be a cation. It has to be an anion. So it's not in my 1-, but it is in the 2-. So sulfate, ooh, that's a typo. Let's fix that. Sulfate, good thing we did this example. Can you flip to your ion chart, please? Sulfate is supposed to be SO4, 2-. So everyone go to your chart and fix this. SO4, 2-. Look at the neighbor and say, did you fix it? My fault. Now I know I have something to fix for the future. SO4, 2-. So, my example, SO4, 2-. So remember, the entire SO4, it's all grouped together, and the whole thing has a 2- charge. So if I crisscross this, isn't this a 2+ and a 2- already? Isn't this already neutral? So this would be a 1-to-1 ratio, right? So I'm going to write FeSO4 because I only need one of each one. In math, do you use parentheses if you only need one of it? Same idea. I'm not going to use parentheses if I don't need to show that there's more than one. There's only one, I can just write it. Good thing we caught that sulfate mistake, huh? Okay, so count out 7. 1, 2, 3, 4, 5, 6, 7, because that's where our practice is going to go. Okay, now let's split them up. So if we can form them from the name, let's split them up into ions. And again, this gets really important when we start doing chemical reactions and anions and cations switch partners and make new compounds. We need to know how they do that, okay? And this is the first step. So we're going to split this up. Splitting, ooh, that's a T. Splitting into ions. And we're going to make like the same chart that we've made before. So formula, cation, anion, number of ions. Same way we've done this before. Ooh, a little crooked, so that's all right. So same chart that we've done before. First example, Ca parentheses NO3 parentheses 2. Out loud, or the name of this would be calcium nitrate. So first thing we need to think about is where are we going to split this up at, okay? Your first clue are the parentheses, right? So the first clue is the parentheses, because just like in math, you know that that means you're doing something separate from the whole group, or you have to do that first in the whole group. So I'm going to just take another color and I'm going to say this parentheses right here, this is my dividing line. That tells me that I'm dividing there because I have a cation and then I have parentheses and then that's my anion. Plus, we already know calcium. We're familiar with calcium. We know that calcium is a cation. And in this compound, there's no subscript after the Ca. There's nothing here. That means I only have one of them. And calcium is in group 2A, and it forms a 2+ charge. That part's not new. Now let's look at our anion. This 2 outside of the parentheses is a subscript. The same way that we were using the subscripts to tell us the coefficients, it's the same thing here. I have 2 NO3 ions. The 3, it's like it's glued to the oxygen. It doesn't move. It is part of that group. It is part of that peanut M&M, and you cannot break it up. You cannot move that 3. Now, if I'm going to figure out the charge of the nitrate, I can do this 2 ways. One, I can look at the chart, or I can approach it like I approach transition metals. Okay? So if you look at the chart, it will tell you. Or if I just think through this logically, I have 1 calcium that's a 2+, and I have 2 nitrates. Well, if this has to add up to 0, then each nitrate must be a -1. Because it has to add up to 0. Again, you could check the chart, check the chart, check the chart. I'm going to say that a million times. Check the chart. Okay? Or you can think it through the same way we did transition metals. So, for this Ca, parentheses, NO3, parentheses 2, my cation is a Ca2+, and I have 1 of them because there's no subscript here. I have 2 nitrate ions, which is the NO3, and each nitrate ion has a -1 charge. So for my total number of ions, I have 1 from calcium and 2 nitrates for a total of 3. Same way we added them before, this is a group. It's a group, and it's just 1 ion. Here we go. Let's do another example. AlPO4. Okay, well, there's no parentheses here. But is there something we are familiar with? Do we already know about aluminum?
Yeah.
Okay, well, Al is that first element. So I know that Al aluminum is my cation. So if I do that, and I split it after aluminum, then that's going to tell me what my anion is already. So for aluminum, there's no subscript after the Al, which means I just have 1 of them. And aluminum is a metal in group 3A, so it has a 3+ charge. I wrote that in the wrong spot, sorry. Oh my goodness. Where's my thing? While I'm trying to get this going, look at the chart and see if you can figure out what PO4 is. Oh, there it is. Let's try the orange one. Look at the chart and see if you can figure out what PO4 is. You know it's going to be negative because it's written second. I found it. Phosphate. PO4 3-. So that PO4, that ion is called phosphate. And the whole thing has a 3- charge. Now if we notice, there's no parentheses, right? So if there's no parentheses, that means there's only 1 of them. So there's only 1 phosphate ion. So for our total number of ions, I have 1 aluminum and 1 phosphate for a total of 2. And also note, 3+ and 3-, that adds up to 0. This is a neutral ionic compound. Another example. NH4OH. NH4OH. Okay. I don't see any metals in this compound. These are all nonmetals. So that's my clue to check the chart. The NH4 is written first. So if I look at my chart, I know that the NH4 is written first, and I know that that is a cation. So that tells me that my cation of ammonium is NH4. So that NH4 is what I'm going to write as my cation. Also note, we have on here that it's a +1, so NH4 plus. Again, we wouldn't normally write the 1 as the charge, but it's written on here because it'd be so tiny that I want to make sure you can see it. Okay? Are there any parentheses in this compound? No, so that means there's only one of the ions. So there's only one NH4. Okay, well, if I know that it's an H4, then that means that everything else after the NH4 must be an anion. So everything after the NH4 must be an anion. So that's an OH. Okay, well, look on the chart and see if you can find an OH. Look on the chart and see if you can find an OH. When you find it, put your finger on it. Did you find it? What's it called? Hydroxide. Okay, this is a tricky one because it sounds like something that would be on the periodic table, right? Because it ends in I. But hydroxide, just think about the name itself. Hydro, like hydrogen, and then oxide, like oxygen. So hydroxide is literally hydrogen and oxygen. And that's what we have here. We have a hydrogen and an oxygen. And on our chart, this is a 1-. Now we only have one hydroxide because there are no parentheses. So there's one ammonium and one hydroxide for a total of 2 ions. Parentheses are a big clue. Let's do one more. Cu3 BO3 2. Okay. Cu3 BO3 parentheses 2. All right, I see parentheses. Do you see parentheses? So I know that that's where this gets split up, is at the parentheses. My cation is written first, which is Cu, which is copper. This subscript of 3 right after it tells me that I have 3 of them. Now copper, hold up, is a transition metal, right? So that means it can have more than one charge. So I don't know what the charge is yet. I'm going to wait and I'm going to write my anion first and then work backwards and figure out the charge of the copper. Okay? So looking at the anion then, the parentheses tells me that this is a polyatomic ion. And I can see the BO3 in the middle. This 2 on the outside tells me that I have 2 of that BO3 group. I have 2 of them. So the 2 becomes my coefficient, and my ion is BO3. All right, well, I know that the BO3 is a polyatomic ion because it's more than one atom in there. So if I look on the chart, I can see borate is BO3 3-. So this is the borate ion. So that 3- tells me what the charge is here. 3-. Okay, so each borate has a 3- charge, and there are 2 of them. So what's 3- plus 3-? 6-. So if I have a total of 6 minuses, how many pluses must I also have if it's neutral? 6 pluses. But I have 3 coppers. So what is the charge of each copper going to be? 2 plus. So if I were to say this name out loud or write the name, I would say copper 2 borate. And if I'm looking at my total number of ions, there are 3 copper ions, copper 2 ions, and there are 2 borate ions. So 3 plus 2 is how many? 5. So it's the same process, but now we're just looking at a group of atoms and we're treating it like one single unit. And we can't break that unit up. And that's polyatomic ionic bonding.